Quickly and easily deliver Jakarta EE apps in any environment, on-premise, in the cloud, or hybrid. Payara Platform Enterprise is a stable, supported open framework optimized for containerized Jakarta EE and microprofile applications. Learn more at payara.fish.
Hello and welcome to the InfoQ podcast. I'm Daniel Bryant, News Manager here at InfoQ and Product Architect at Ambassador Labs. I recently had the pleasure of sitting down with Matthew Skelton and Manuel Pais, software delivery consultants and co-authors of the book, Team Topologies. I've known Matthew and Manuel for quite some time now and have learned a lot from them. Matthew has long been discussing the pragmatic implications of Conway's Law and team design, and Manuel has led the DevOps writing team here at InfoQ for a number of years, and he's covered all aspects of software delivery. Practically every online conference I'm going to at the moment, whether it's focused on architecture, DevOps or the cloud, the Team Topologies book they wrote is mentioned, often alongside classics such as Accelerate and the DevOps Handbook. I was keen to dive into the core ideas of the Team Topologies book and explore how they relate to the modern role of software architect. Hello Matthew, hello Manuel, thanks for joining me today.
Good to be here, thanks.
Nice for having us.
Could you briefly introduce yourselves please?
So I'm Matthew Skelton, I'm the co-author of the book Team Topologies along with Manuel. My background is in software development originally. I started off building software for brain imaging machines and then moved into other stuff around kind of oil and gas and then local government and then financial services and then other things. And now I spend most of my time helping organizations to become more effective at building and running software.
I'm Manuel. I'm the other co-author of the book. So I have also a background in computer science. I started as a developer 20 years ago. I've had build and release management roles, testing, team lead, and a lot of consulting around DevOps and continuous delivery. And the book came about because we found issues around how teams were interacting. And so today, my role is as an IT organizational consultant and trainer as well.
Awesome. So we're talking off mic. This is the InfoQ architecture podcast. So the typical persona is architect or tech leader. Why should someone with that kind of role in modern software pay attention to the content of the book, Team Topologies?
That's a really great question. And it comes down to this. The software architect or the systems architect of the past who focused almost exclusively on technology, whether it's running applications or whether it's bits of off-the-shelf equipment or software or whatever, that focus on purely on the technology is just not relevant anymore. We now know through plenty of studies that there's strong evidence that something like Conway's Law is actually real. So Conway's Law being this kind of mirroring of the communication structure in the organization to the likely software architecture that we're going to produce. So it's not a one-to-one mapping, but there is a force there, a kind of socio-technical mirroring happening. What's interesting, if you read the original paper written by Mel Conway in 1968, it's really rich and there's lots and lots of interesting kind of ideas and detail in there. Effectively, the shape of the organization is a constraint on the solution search space. So if our organization is set up in a particular way, we may never find a particular solution. So actually, this is a strategic problem. That's why it's interesting from an architectural point of view. And so modern architects, when we're thinking about it, if you're an architect, your job involves dealing with software. You need to know about software. You need to know about modern kind of cloud services and probably IoT and things like this, big data. But you also need to know about things like Conway's Law. You need to be thinking about how HR is interacting with the organization. You need to think about how facilities are laying out the desks in the offices. You need to think about how the sysadmins are managing Slack or Microsoft Teams or your chat tool. Because all of these things in a socio-technical context affect architecture. So the old architecture effectively is dead. The new architecture is very much alive. And that's kind of exciting from my point of view, but it's also maybe slightly daunting. There's a lot to think about. And obviously, we cover some angles, some of those aspects in our book, Team Topologies. But this is entirely relevant for architects to be thinking about these new dynamics inside the organization.
Yeah, and I would just like to add that we still see some people who are thinking that they don't need architecture because we have all these great cloud offerings and services. But as Matthew was saying, it's kind of reducing the scope of what architecture is. And it's true that cloud helps us offload a lot of what used to be some concerns for development teams, but there's still a lot that we need to know around how do we put together these different pieces. And then all the way up to thinking about kind of what Matthew was saying about the kind of organizational architecture and how that impacts the overall system architecture. And so there's a lot that still needs good architecture. We still need teams to have pretty good capabilities around technical architecture as well. And so it's definitely something that is very needed to create efficient modern software systems, even though we might not always need an architect role per se in every team.
Very nice. Now, I'm a big fan of the book, as you know. One thing I've used sort of as a tool for Architect is helping folks sort of map their old world to this new world kind of being pitched. And I really liked the team APIs description from the book. Yeah, so you need to do about APIs. Everyone knows what an API is these days, right? So could we dive into a little bit more? When you talk about team APIs in the book, how does that relate to, say, software APIs? And what's the advantages and disadvantages of thinking about team APIs?
So API means application programming interface. It's a description of how a bit of software like a library or a component or a service is supposed to be interacted with, how something else calls it, and the shape of the data and the shape of the response and so on. So we took this very technical term deliberately because it would resonate with engineers and people who write code. And we're inspired or guided by Conway's law, where we're thinking about this kind of technical mirroring between the organization shape and the likely system architecture. If you have software APIs, then why wouldn't you have a kind of interface into the team? Because you're likely to have a mirroring. So effectively, the team API is a definition of the interface into a team. So it covers a whole bunch of stuff around kind of what the team's working on, what they're responsible for, how you can contact them, which other teams they're expecting to talk to over the coming weeks, which teams they're currently talking to right now in order to achieve something. It seems to be really useful, doesn't it, Manuel? There's various organizations who've started to adopt this, and it's kind of helping them think about the responsibilities for different teams.
We've had several people telling us it's almost a change in perspective because many teams already have a sort of team agreement or team charter, which makes a lot of sense for the team internally to agree on what is our purpose, how do we like to work, what practices we want to adopt. At least they have this kind of North Star or, goals for the team, which is all super valuable. But the team API is then saying, okay, let's kind of flip this to some extent and think about the teams around us, the teams that need to interact with us. Just like a service that is external needs to interact perhaps with the services that we maintain. And so it helps people think about kind of the same information to some extent, but how do we make this now clear to other teams? And sometimes there's missing information in those team agreements because it's implicit knowledge inside the team that teams outside don't have. And so that is very helpful, especially today in this COVID pandemic aspect, because most teams work and most people working from home in many organizations makes it even more difficult to understand when and how should we contact other teams. Where is the information about, their systems? When are they going to release some feature or, do some piece of work? And so we found that many organizations found it useful to have their teams creating these team APIs, making them visible to the whole organization. So we reduce the kind of load on understanding the communication patterns, especially in distributed remote working.
You mentioned something, Emma, and I've heard you both talk about, and I've learned a lot from you both about like cognitive load. I think that's a thing that when I heard of it and when I've talked to other people about it, they all, including me, recognize it straight away. Cognitive load with these big systems we're building now, even the monoliths, to be honest, it's really hard to understand all the technology. I'm guessing what I'm hearing you both saying is, yeah, sure, it's hard to understand technology, but it's hard to understand the social people aspect of it in the same way.
Yeah, I would say many things contribute to cognitive load. So the amount of things, if you like, different aspects that teams have to know about to be able to deliver their work. And so without going into a lot of detail, because you can distinguish different types of cognitive load, but there's definitely an aspect of, we have to know about technology, we have to know about practices, and we have to know about communication with other teams as well. We have to know about our internal organization processes as well. And so there's a lot that these teams need to know. And often what's left out, or they don't have enough capacities to actually grow their understanding of the actual business and the customers that they're trying to serve. So you get these teams who are almost kind of order-taking teams where there's a backlog that someone else created and prioritized for them to deliver, but not because they don't want to, but they just don't have the capacity to actually dig into who are our customers, what are they trying to do, what problems are we trying to solve. And so the book, we talk a lot about fundamental topologies, interactions, etc. And it's all really focused on reducing cognitive load of teams so that they can be more autonomous, which is something that we hear a lot from Agile and DevOps to some extent, but we don't always actually have good techniques and practical approaches to reduce that cognitive load so teams can actually be more autonomous and have a strong sense of the business needs.
It's a case of trying to make teams autonomous and decoupled, so kind of loose coupling between teams.
We go back to Conway's law as well.
Exactly, go back to Conway's law. So we want a fast flow of change. That's what we need. That's literally on the front cover of the book, Organizing Business and Technology Teams for Fast Flow. That's the subtitle. So that's our kind of starting point. If you want a fast flow of change, you need a limit on the cognitive load that a team is going to find itself with for a particular system. Otherwise, it won't be able to deliver rapidly. If you want a fast flow change, you need to have kind of end-to-end ownership. You need no handoffs. Sometimes it's called you build it, you run it. Some people call them DevOps teams, whatever. You build this thing and you run it in production, and you get that very fast feedback coming back from the live environment. So that's that kind of fundamental starting point. And of course, what we've got here from an architecture point of view is if we've got a focus on making sure that teams are substantially independent and decoupled, then guess what? Our architecture is going to flow from that. So we've got a nice loosely coupled architecture with well-defined services and so on. And so that, again, that's why it's interesting from an architect's perspective. There's plenty of examples of companies who have really been doing these kind of approaches for many years. The classic one is Amazon Web Services, AWS. Whether or not there's a famous memo which might be kind of apocryphal, which might be made up, but it sort of doesn't matter whether it's made up or not, because the principles in this memo where it talks about each team must communicate only through standardized interfaces and there'll be no other kind of inter-team communication allowed and all the interfaces must be externalizable and all this kind of thing. So those principles, if you look at them through a different lens, what they're trying to do is make sure we've got team autonomy, team independence, loose coupling between these different teams, and therefore the architecture will flow from that. So that was the insight from Jeff Bezos back in whenever it was 2002. And clearly that's helped AWS to scale. This kind of loose coupling. If you listen to the architects who really get this stuff and have seen lots of software in lots of different contexts, they're always talking about loose coupling, asynchronous, message-driven systems. And these systems have existed since the 1960s. It's not like we're inventing them. They've been proven for decades. And so let's have our teams in the organization loosely coupled, substantially independent, and with well-defined kind of communication between them, ideally asynchronous. It means that some of these kind of big frameworks, kind of scaled agile frameworks, they might help some organizations to get out of a swamp, to get onto dry land. But ultimately, a lot of them focus on continued synchronization every 6 weeks.
Release trains, all that kind of thing.
Release train, whatever it's called. There's lots of different versions, but lots of synchronization between multiple teams. But that means that these teams are not loosely coupled. And therefore, the architecture is likely not to be loosely coupled. So you've got a kind of local maximum there, which is difficult to get away from. So our focus in the Team Topologies book is on how the teams interact, the team API being a kind of a key aspect of defining how, it's a thinking tool, really. It's not something you define and then walk away from it. It's a way of thinking. It's a way of discussing. It's a way of having conversation. So we focus on how to make sure that teams are loosely coupled and independent and can achieve a fast flow. And therefore, the kind of systems that we're building should be a better chance of producing systems that have similar properties.
A caveat there, perhaps, is that like in the example of AWS, where they made this very strict separation between teams and therefore allowing different services to evolve independently much more quickly, but also because they correctly identified, or they probably had a good idea of what those independent services are, which is something else that I see still a lot. And, if you're on Twitter on a regular basis, you now and then see people complaining about even things like microservices. I usually say, microservices is step 10, not step 1 of identifying, what are your independent streams of work. Because you might have a great microservices architecture where, in theory, each team is responsible for a nice independent microservice with their own data store and everything. But then when you look at the business needs, the kind of offerings or features that you need to deliver, or even user journeys, when you need to deliver those, then you look at the architecture and you need to involve multiple teams, 4, 5, 6, and teams to actually deliver that thing, which is what brings you business value. So before we actually go into microservices, it's not a purely technical decision. They need to be aligned with the independent kind of streams of business value streams, if you like. And that's something that's often missing as well. So Conway's law helps us, but we also need to, whether we're applying ideas from domain-driven design or, on github.com/Team Topologies, we have a number of kind of tools and techniques and templates. So one of them is called independent service heuristics, which is, we joke that it's like DDD light because it's just a simpler set of questions that can help you start thinking about what are really kind of independent services that we can then align with different teams. And therefore, we talk about stream-aligned teams in the book. And so regardless how you're doing it, whether, a simple tool like that or more involved domain-driven design, which is great, it just, requires more understanding. We need to start there or have that as one of the key points of how we're thinking also about, again, architecture and teams together for fast flow, for independent streams of work. Otherwise, if we focus first on let's do microservices because it supposedly gives us more independence and faster flow, but we haven't thought about the actual independent value streams for our business, then we get to a problem there where we haven't really achieved faster flow.
Definitely be nice to come back and sort of touch on some of the boundaries you mentioned, I think, there, Manuel. That's super interesting. Before we do, I'm really keen to dive into the teams that you both mentioned, because I really enjoyed seeing the presentations and it resonates with a lot of folks. You get a lot of nods in the audience when you present the 4 fundamental team topologies. You've already mentioned stream-aligned teams there, Manuel. Will you both dive into the 4 types of topologies?
Sure. Our starting point, like I said before, is a fast flow change. If you want a fast flow change, we want no handovers from one team to another. So instead of having a separate dev team, QA team, release team, ops team, just have one team that's responsible for build and release and runtime. You build it, you run it. Now, that kind of model has been in place for quite a few years in lots of different organizations. We didn't invent it. But what we did is put some sort of principles around it and some additional kind of context and justification. And so we're starting with this fast flow change, but we also need rapid feedback. So we need good telemetry from digital telemetry from production and the live systems, and also feedback from our customers. We need to get close to the user of the system. So there are other techniques for getting that kind of feedback. But then if you have a team that is responsible for all that stuff, over time, they will have to deal with more and more and more things. They'll have to deal with security, governance, audit, infrastructure, logging, the whole works, right? And then they start integrating some Internet of Things and they start having a mobile app. And at some point, the cognitive load on that team gets too high. You can't do enough of that. You can't keep growing teams. A team as a high-performing unit is limited to, depends, but something like 8 people, 9 people. In some organizations with much higher trust, you can get up to about 15. But even then, that's kind of like 2 teams paired together. There's a limit on the team size, basically. So therefore, there's a limit on the cognitive load. Yes, you can hire more experienced people, but you still get to a limit. And so at some point, you have to say, what's the most important things that this team needs to be focusing on and what can be offloaded somewhere else? And that's where these 3 other team types come from, which are the enabling team, the complicated subsystem team, and the platform team. And their primary purpose, effectively, of these other 3 team types is to reduce the cognitive load on these stream-aligned teams. And that's a very different way of thinking about the purpose of these kind of teams, because it helps us to have a very honest conversation about where we need that kind of investment, where we need that focus. It means that, for example, when we talk about a platform, instead of going ahead and building a great, big, massive technology platform, our focus is effectively, our starting point is we are there to reduce the cognitive load on these stream-aligned teams that are using your platform. And that's kind of it. There isn't really anything else that you're doing. There isn't really anything else that you should be doing. That's always the focus. And it seems people keep coming back to this and keep telling us this is a really, really useful framing or kind of way of thinking about these other teams, other kind of bits of technology in the organization. It keeps us much more honest and nimble, I think, much more lean in that sense, about how much other stuff we need to build and where we have other kind of teams in place.
With platforms in particular, it's often hard for people to move away from the kind of traditional idea of platform as, well, this is where we centralize shared services. And there's this kind of difficulty to think about focusing on what are the needs of our internal customers versus what are the things that are shared, and therefore we're going to build them in this platform. So this type of modern platform is much more focused on, I like to call it has to be platform as a product. So that means we're looking at our internal customers, and it's not so much about what should be where, should this be in the platform or not, but actually the answer, as Matthew was saying, comes from, does this help reduce cognitive load? At least one streamlined team usually will be then applicable for multiple teams, but you could possibly even have a platform service that's just helping one team offload some of the cognitive load they have today around parts of the system or of the tech stack, actually, which are not really very meaningful in terms of adding value to the service to the end customers. There's a quote I like a lot from Paul Ingalls, who is CTO at Uswitch, and they used to have almost 100% autonomous teams without any platform. And he said they got to a point where each of the teams had to make so many decisions around infrastructure and services at a kind of low level part of the stack, if you like, that they realized we need to have some sort of platform to help these teams offload, because what he was saying is that, we're spending a lot of time making low level decisions which have low value for the business. And so because there's that limit on our capacity as a team that has a limited size, then what are the things that we can offload? But so the modern platform means that we start with the needs of the teams, which is the same as you do for a product, right? You don't start a startup where you're not looking at what are the needs you're trying to address. Or if you do and you start just building stuff, a high chance they won't succeed.
I like that, man. It reminds me of, I saw a talk. I think it's Matthew, maybe both of you, talking about the thinnest viable platform, like kind of the MVP, and minimum viable product. And I really like that concept, as in, because I've definitely seen teams when I was a consultant that built out amazing kind of mini Amazons, mini clouds without even talking to the developers. Yeah, and I'm like, no wonder they're not using it. You never talk to your customer.
And crucially as well, I mean, the thinnest platform you can build is a wiki page with like a list of 4 services that Amazon or Azure provide, or Google Cloud provide, or whoever. And someone has curated an experience for the engineers who are using this. And they say, right, if you use these 4 services like this with this kind of configuration in this way, it'll be really easy for you to build on AWS. So that's a platform. Just because you haven't built any technology yourselves, you've still curated something. You've still reduced the cognitive load on these teams who are going to use it. And that's the ultimate goal. And that's actually better for the organization because there's less extra code, it's quicker, there's less to go wrong, it's more nimble, and so on. So everyone wins, basically, if you take this kind of thinnest platform approach.
Yeah, there's also sometimes misunderstanding that a good platform means we're building similar services to what already exists. And so that's not what we're saying. We're saying leverage as much as you can of your third parties, and actually healthy kind of dynamics that you are competing with those third parties, so that teams can have that option like, okay, am I going to use the AWS service? And on top of that, I have to perhaps write all this code and understand all the configuration, etc. Or do I have an internal platform service which actually makes that much easier for me? So what they're focusing on is kind of almost like a translation that AWS cannot do. AWS doesn't know your specific internal needs for your teams, but they are your customers and you are working in the same organization. So it should be much easier to understand what is a useful abstraction here or a useful wrapper here, so that I'm not rebuilding the service. I'm using a third-party service. But on top of that, I'm making it much easier to consume for our internal teams because I'm abstracting away details that they don't need to know. They can if they think they need to, and they can dig into it. But here's a more competitive, between quotes, service internally, which means you have to know a lot less about that specific cloud provider service, how it works.
And that's actually a really important role for the modern architect, particularly if you're combining Team Topologies principles with something like Wardley mapping. So you're thinking about the strategic landscape, you're thinking about how things get commoditized and whether you need to custom build or whether you can just consume as a product. There's an organization based in the UK called Foot Asylum. They sell clothing. They actually used a combination of platform thinking and flow thinking from Team Topologies with Wardley mapping. We've actually got a case study on our website from them. And it was just amazing to see it come out. We hadn't been working with them at all, but they'd gone ahead and done this. And it had really helped them to work out what they needed to build internally in their platform. And they saved loads of effort because they realized they didn't need to build a whole load of stuff. They used kind of Wardley mapping principles and then mapped that kind of onto the Team Topologies principles and said, our platform can be much smaller than we thought it needed to be. So they saved a lot of effort and they can move more quickly. So that's a great focus for kind of architect minds and activity, is around that kind of strategic part of working out what's the minimum amount of platform or the minimum amount of stuff that we should actually be building here. Not the biggest amount, the smallest amount, keeping it nimble.
I like this. What I'm hearing from both of you is there's a mind shift here for the modern architect. Yeah, and I mean, I've definitely seen this at conferences I've been to, or when I could go to conferences, folks saying you need to think more about the human factor, like you're a technical leader, not just a boxes and lines type person that maybe I did, to be fair, 10, 20 years ago. I'm thinking the mental models, the opportunities for software architects now is probably quite vast. You need to focus on where you can add the most value.
Yeah, and potentially be able to skip from one kind of Zoom level to another, if you like. So sometimes you're working at the strategic kind of products, Wardley mapping type level. Other times you're working at the team level between multiple teams. Sometimes you might be just working at the value stream level. There's far more opportunities than there perhaps were in the past. And that's partly because software systems now involve more people. And therefore, the social aspect becomes more important and also kind of more complicated, fundamentally, potentially even complex in terms of how they work. So it's not surprising there's additional dimensions that have come in.
We're also seeing, as we talk to different organizations that are adopting some of the ideas in Team Topologies, or during the online trainings that we run, we often see people start having this question: if we want to think about the different types of teams and what are the platform services that we need, or what are the enabling teams that we need so that we can have streamlined teams or product teams, if you like, go faster, then you also start thinking about who is looking into this, who is looking at what is missing and what lies in between teams, right? In between the team boundaries. And so that could perhaps be the role of a system architect or enterprise architect. But as you were saying very well, Daniel, you need to have this kind of understanding of teams, of Conway's Law. And also it's a matter of having the responsibility and having the authority, if you like, or the possibility to make those changes at the team level, if that's what you need. If you realize, well, we need an enabling team, which is going to help some of the teams understand better how to do monitoring, how to do telemetry for their products or services. And so there's an opportunity there as well. What we usually say is that whoever in the organization makes decisions about organizational structures, team structures, and composition needs to work together with whoever makes decisions about the software systems and the architecture. Whether that's the same person or team, then great. Or if you need to bring together HR people and software architects together to make those decisions and think about what they need, that also works. It depends from organization to organization, but clearly there is a kind of broader view of what architecture is, not just systems, but the architecture of the teams, essentially.
And really crucially, we're in a situation, in a kind of business situation where things are changing very rapidly, and that's no longer going to change. We've got a really rapid expansion and acceleration of how the technology is playing out. Cloud, IoT, apparently now you can play Doom on a pregnancy test device. I mean, it's just amazing, right? The amount of compute power which you just throw away. And that's just absolutely incredible, because the speed of technology means the architects need to be thinking about how can we set things up to change. We're not architecting for things being static. We're helping things to evolve. And that's a very different way of thinking.
Evolution.
Yeah, evolution. It's a very different way of thinking from the past, where we kind of design something that was going to be basically the same for many, many years, or 5 years or 10 years or something. Now, the role of the architect is more about working out how to make sure that this thing can adapt very, very quickly, potentially over the course of months or certainly years. And that's a key aspect of what we talk about in part 3 of Team Topologies, is setting things up for evolution, listening to the signals inside the organization that tell us, for example, that although we got the domain boundary right last year, the domain's actually changed. The international regulations for trade in this sector, or the kind of compliance requirements.
GDPR, classic.
GDPR, all of these kind of things have changed. We're now no longer able to send this kind of data from this country to that country, and so on. And so we have to expect this stuff to evolve. And so again, a good role for architects is to get involved in thinking about how we would detect in an organization that we've got our domain boundaries wrong, that they were okay in the past, the external environment or the internal business environment or whatever has now changed, and we now need to be able to evolve the system. And that's incredibly important responsibility for architects to be able to do that. And so some of the Team Topologies patterns will be part of that architect's toolkit.
And also, even besides the rapid change in markets and so on, also just admitting that you might get it wrong. You're probably going to get it wrong. The kind of the independent services that we were talking about, or the bounded context in domain-driven design kind of terminology, you're going to make mistakes. So we should be expecting that we're going to be sensing for, well, actually, we thought these two seem like kind of independent and kind of have their own different life cycle. But then what we realized in practice is that these two teams are often having to collaborate and kind of sort out how their different APIs need to evolve to be compatible or whatever it is. And then we realized, actually, we probably didn't get it right. And so having the honesty, or not being afraid to realize that we need to constantly evolve and sense when actually we didn't get it as right as we thought, and so we need to adapt. That's kind of one of the core ideas of Team Topologies as well for me, or one of the ideas that I was trying to get across, is that we should not be thinking about static boundaries, should not be thinking about static models even for our team structures. Things like Spotify model have been quite helpful, like Matthew was saying, for many organizations who are in a much worse place. But you need to be careful not to look at it as a static model. We need to have evolving organizations. It's much more like if organizations would be like a living organism that needs to continually adapt. It's not a static thing that we just follow this model and expect it to work indefinitely.
Very nice. I'm conscious of time here, gents. Other than, say, buying the book, which everyone should do, of course, what's the best way to get started in this kind of stuff? If folks have liked what they've heard, maybe they're a practicing architect, they go, yeah, I need to start thinking about this, building the mental models, trying some of this stuff out, learning in a safe environment. How would you recommend folks get started?
So just visit our website, teamtopologies.com. We've got some case studies on there. If you go to teamtopologies.com/examples, you'll see some case studies from organizations that have adopted the Team Topologies since the book was published. The two most recent examples on there are, as I mentioned, from Foot Asylum, which is a retailer, and USwitch, which is a utilities comparison website. Really great case studies there. And there's some good level of detail that will resonate for architects. There's also some other kind of online learning that we've got in there, lots of videos, talks, slide decks, this kind of thing. Sign up for our newsletter because we've got lots of things coming in the future. For example, we plan to do a series of kind of visual patterns and anti-patterns to help explain some kind of good interpretations of what we've written about and some less good interpretations of what we've written about. There may be some anonymous examples of organizations that we've seen that are doing it really badly, whatever. Of course, we've got training as well. So we spent the last few months really reworking the training that we had before, which was all in-person training, reworking that into fully remote first. And actually, I'm sure this is not a surprise to many listeners. In many respects, the remote training is actually better than in-person. Because, for example, you can save a copy of the mirror board that we're using, the digital whiteboard, save a copy of that. And that's really easy for everyone to take away and remember what we're doing and that kind of thing. And we're actually in the process of collaborating on some additional training as well. So we're collaborating with experts in other fields. For example, our first kind of collaboration training is around DDD, domain-driven design. So we'll have DDD experts giving that training, but it's contextualized to Team Topologies. And we'll be doing hopefully some other training as well, maybe around architecture, maybe around Wardley mapping, things like this, and bringing in additional ideas into this space to explore it more and to bridge some of these areas which sometimes historically been a bit separate.
Super. I'll be sure to link all that in the show notes. Well, thanks for your time today, gents.
Thank you, Daniel.
Thank you so much.